parents. So what we are working on this week is alternative ways to solving addition problems that don't just go with the regular algorithms that we were taught. An example of a regular algorithm, the way that we most commonly would solve an addition problem is we say, what is 7 plus 6? We know that 7 plus 6 is 13, so commonly we would put a 3 down here and carry 6, 7, 8, 9, 10. So that would be 103 regularly. But we are trying to get the students to look at other ways in which we can solve these addition problems. And one of the ways that we have introduced that is called lattice algorithms. And I will show you an example of what a lattice algorithm looks like. So we would set it up like we regularly would. And then because we have 4 numbers in this, each number will get its own little square. We then go to just solving each like we regularly would do. So we would say, what is 8 plus 7? We know that that's 15. So in the lattice algorithm, we will write a 1 and a 5. We'll do the same for the following. So 6 plus 7, 13. 5 plus 6 is 11. 5 plus 3 is 8. So we have nothing up here, so we put a 0. We will then pull this 5 down. And then we will start adding in this way. So we will do, what is 3 plus 1? 4. 1 plus 1? 2. 8 plus 1 is 9. Then we have the 0. So this is what our answer is. You could then check the answer in the traditional form if you would like, but this is just one of the ways that we are trying to get the kids to think of adding things in a way that is different from what we would regularly do. The next way that we have introduced is called left to right algorithm for addition, or the partial sums algorithm. This kind of comes in with the other example that I showed you when we're adding bigger numbers, and this is really helpful to students, especially in the younger years, because they may not be used to adding bigger numbers, and this is a simpler way of getting the same answer that we would regularly get by doing it traditionally. So in this example, we are going to have 568 plus 757. What we're going to do is we're going to say we have 500 and we have 700. So what is that? So let's add that, 500 plus 700. So if we wanted to use counting on, we could use 7, 8, 9, 10, 11, 12. So we would have 1200. We will then go to the 6th, and we will say that's a 60 and that's a 50. So we go from adding the hundreds to the tens to the ones. So we will add 60 plus 50, which will give us 110. We will then go to the ones place, 8 plus 7, and that will equal 15. So then, to to get our answer, we are going to take the answers that we got from the hundreds, the tens, and the ones, and we are going to add all of those up. We're going to line them up a bit better. So we'll have 5, 2, 3, and 1. So that would give us 1,325 for our answer. But what if we have a bigger number than that? So let's go with 2,424 plus 1,220. So how would we do that? We'll do the same thing except for the fact that in this case we're going to add thousands. So we'll say that's 2,000 plus 1,000. That will give us 3,000. We have 400 plus 200. That will give us 600. We have 20 plus 20, and that will give us 40. Then we go to the ones, and we have 4 plus 0 equals 4. So we are then going to add all of this up. 4, 4, 6, and 3. So we would get 3,644. And if you would like your student to check this using the traditional algorithm, we could do that as well, just to make sure that their answer is correct. So this would just look like and we see that that is in fact correct. So that is where we are at in terms of this week and introducing alternative methods to completing addition problems. And if you have any further questions, please feel free to email me or contact me. And that'll be it for today.